Assalamu alaikum warahmatullahi wabarakatuh. I will start my presentation titled The Roles of RO Membrane with Desalination. This slide shows my published books and patent and articles. My presentation will follow this outlines. I will start with RO membrane deliberation method, then application of RO membrane, and last about to conclude the result of RO membrane deliberation. Introduction: why we need the desalination? We know now the problem of sample nada and the importance of increase the drinking for industry, for people, for out of usage in Egypt. So we want the desalination in Egypt. So the main thing now we go to the membrane. What is the main factors affect on the membrane? We should select the best material. When we select the best material of membrane, the material should have some properties. The main properties, the first is that the membrane should have good permeability, also good mechanical stability. Why? Because the RO membrane work at high pressure, more than 50 bars. So the membrane have bad mechanical stability, so this membrane is not suitable for the application of membrane. So these factors are the main factors to select the material for RO membrane. This figure or this table shows the main polymers used for RO membrane and other applications. Why we use the RO membrane? Because with the RO membrane we can get the beam selectivity. What are the main beam selectivity? We know that seawater has water and salt. The RO membrane can separate the salt and we get the pure water. So, what type of membrane we must prepare? We must prepare a symmetric membrane. With an asymmetric membrane, we can get high flux and we can achieve liquid molecular separation. If we use symmetric membrane is not suitable for desalination. Why? Because the symmetric membrane, the flux is very, very low, and so we need water with high value. So the symmetric membrane is not suitable for the desalination. And in our group flat membrane, we use permeable membrane with a polymeric material. Why? Because with a polymeric membrane, we can get high mechanical property and good chemical stability and maintainable microstructure. And also we prepare the membrane with ceramic, but most of our research we use the polymeric membrane. This figure shows how can we prepare some RO membrane. We can prepare by different methods. The main method we use in our lab phase inversion, and we also use the interfacial polymerization. The phase inversion has different types. The main type is the immersion precipitation. What is this process? This flow sheet shows the main steps for the immersion precipitation method, which we use in our lab. The first step, we select the polymer and show which solvent is suitable to solve this polymer. This step is the mixing step or the dissolving step. After that, the polymer solution will casting, use the doctor plate to with the acquired membrane. Then we go the third step, the immersion and drying and the testing. This is the main steps we use to prepare our membrane. This flow sheet shows the main, but this is for our the chemical engineer. We prefer this type of flow sheet. So we for this build. The tri-phase diagram. Tri-phase diagram are the arm membrane, as we discussed before. The arm membrane should be asymmetric. What is the meaning of asymmetric membrane? Asymmetric membrane, this membrane should have different layers. The membrane should have porous layer and dense layer. What is the meaning of dense layer? This layer is a compact layer. There is no pores. The main point for that, this dense layer should very, very thin, in range nanometer. With it, if this layer increased, this means the flux will decrease. This is relation between the flux and the dense layer. When the dense layer is increased, flux will decrease. So we want the inverse. We want the high flux and decrease dense layer. How can we characterize the prepared membrane? We characterize by different methods. The main method is the scanning electron microscope, and the tomophones microscopy, and the trial, and the mechanical quality. The SM is very important. Why? Because we will know the structure of membrane. For example, this the membrane number 1. This membrane is non-porous membrane. This membrane is not suitable for the desalination. Why? As we said before, because the dense layer is very, very large, so the flux very, very small. So this type of membrane is not good for the desalination. So we search this for this type of the membrane. The porous layer is very large, and the dense layer is very, very small in nano. In nano thickness is nano. Okay. So if we find this type, so this membrane we will not testing for the desalination. The membrane was the same. We find this membrane is suitable for desalination. Okay. When we get this membrane, we will test in the RO unit. This is the feed from the seawater from البحر الأحمر والبحر المتوسط, Mediterranean Sea. This is a pump. This is the housing of the membrane. We collect the pyramid in this tank. In the desalination, the membrane should have high flux and the rejection more than 90%. If the membrane is good performance, so this one we get the best membrane. If no, we improve our characterization of the membrane. We can change the composition of the polymer and the solution. We get the flux from this equation and get the rejection from these equations. This is the flow sheet shows the main types of the membrane. Our work in the RO membrane, as we said, the RO used for the desalination. This is other application also can be used for RO membrane. When we test the membrane for RO, we should think about some parameters as an operating pressure and the operating temperature, the thermal treatment, and preparation process. I will now show an important flow sheet for our RO membrane. So in the project, this project we work from 2003 till now. We search for new membrane for desalination. This is the flow sheet starting from the polymer and solvent. We use cellulose acetate and DMF. And the new idea in this one, we prepare two types of nanomaterial by biological and this industrial. And we prepare also hyper branching polymer. Till now we succeed for the we don't succeed with the nanomaterial from biological method, but we need the from industrial method. We test all types of this nanomaterial, also hyper branching and the polymer solution from cellulose acetate and solvent. We get good performance, but till now we don't reach to 90%. We try to do some progress for the composition of polymer. We try now to increase the percentage of polymer material in the solvent. Conclusion: the RO membrane can be successfully developed with phase inversion. We can test the characterization of prepared membrane by using SCM, porosity, FM, TEM, and swelling degree. This is some example for characterization which we use to test the performance and the characterization of the prepared membrane. Thank you and welcome for all questions.